Okay, for the next example, the next video, I'm going to show you how to solve equations. So this is useful to find x-intercepts, and I guess just solving values for x in this equation here. It looks a little bit scary, but actually it's not as anywhere near as scary as you think. Imagine if I've got this here. I mean, this could be a graph of y equals x plus 1. And what I want to know is, when does y equal 6? Okay, or in this equation I want to know what what value of x will give me 6. Now if I draw this graph here, x plus 1, that's going to be like this. That's where the line would have gone, and the other line goes up there. What I'm asking is, when the y value is 6, what values of x will they be? Okay, that's essentially what I'm asking. Now we know that for this modular sign, it makes it a negative value a positive value. So we could see here that x plus 1 could be equal to positive 6, because when you do the absolute signs on 6, it will just stay positive 6. So x plus 1, it could equal 6. Or x plus 1 actually could equal negative 6, because if that's negative 6 in there, then the absolute signs make it positive, so the answer is 6. So what I suggest doing is actually making two parts to this. Making a positive part and a negative part. Okay, so I'm going to say that x plus 1 actually equals 6, and actually, what I'll do it this way. Sorry, I just remembered something. So make it positive out here. So this answer, this thing in here, could be positive to get to 6, or it could be negative to get to 6 as well, because we know that the absolute sign makes everything positive. So that answer in there could actually be negative 6. So this one is relatively easy to solve. I just get that x equals 5. This one over here, I'm going to divide both sides by a negative 1 to make it x plus 1 equals negative 6. And then I'm going to minus 1 from both sides, and I end up getting x equals negative 7. So my two solutions would be negative 7 and positive 5. That's when this line, this absolute sign, equals 6. Okay, so we do it in two sections like this, positive bit and a negative bit. And I feel like this will always work for you. Let me show you another example where this time it's not so much what does it equal. This is saying, when is it less than 2, or when is it greater than 2. This one is a little bit more complicated, but it's essentially the same idea. So yeah, when is this graph less than 2? Again, I suggest doing it in two parts. That's the graph of it if you wanted to see. What I really want is, I want all of the values between this point here and between this point here when it's under 2. Okay, so I set it up like this. Okay, this one gets a little bit trickier though. So I've got a positive part and I've got a negative part. So my positive part, x plus 3 is less than 2. I can solve that relatively easily, and I get x is less than negative 1. Okay, that's not too bad. The next one's a bit trickier. If I this is a negative. If I divide both sides by a negative, or multiply both sides a negative, then you have to change the sign. The way I can prove this to you is that I can use this. I can say, if negative 1 is bigger than negative 2, and that's true, I could divide both sides by negative 1 and get 1 and 2, but now which one's bigger? It's actually the 2 that's bigger. So I had to swap the signs. Okay, so for this one, when you divide by a negative, you actually have to swap the sign, so it becomes greater than negative 2. And then I simply minus 3 from both sides, and I get x is greater than negative 5. And so now what I've got is, I've got the answers between negative 5, greater than negative 5, and less than negative 1. And if I look up at my graph, it looks pretty good. That looks exactly what I want. Okay, that's part 3 of the video, Modulus video. The next one will be dealing with the one on the textbook. I know I said that in the last video, but the next one definitely will be dealing with the ones in the textbook, and equations like, where are we? Equations like this one here. So question 2 and 3 in your textbook, I believe.